So in this lesson, we are going to talk about atoms, ions, and molecules. And so let's start with atoms. Okay, so let's talk about the concept of atomism. Chemistry is the study of matter and its properties. So matter is the stuff that makes up our universe, like us, we're part of the universe. And the word properties refer to things that we use to describe matter, characteristics, like what color it is, okay, or does it burn at this temperature, things like that. Now, the main idea in chemistry is called atomism. And that's the idea that matter is made up of these little things called atoms. So you could say that chemistry is the study of nature from an atomic perspective. Okay, so you look at things in terms of what's going on with the atoms that make up the stuff. Okay, so the idea of atomism started off with the Greeks. A Greek philosopher named Democritus, around 460, who lived around 460 to 370 BC. And the word atom, okay, the Greek word for it is atomos, literally means not cut. So a prefix in Greek means not. Tomos means cut. Okay, so if you heard of tomography, they cut slices of like images, like cross-sectional images of things. Those are the technology is called, the way of doing that is called tomography. Okay, so atomos means not cut, and so literally what an atom means is the smallest bit of matter. In other words, if you imagine a piece of matter, cut it into little pieces, eventually you get to a point where you can no longer cut it. So that's the smallest bit of matter. That's what Democritus called the atom. Okay, so what Democritus proposed was that the universe is really just a collection of atoms, and in between those atoms, there's nothing. Okay, so the universe, you add up the atoms and the void between them, then you get the universe. Okay, now the idea of atoms did not really flourish until much later, because the more influential Greek philosophers at the time, Plato and Aristotle, did not believe in it, and also religious people had a problem with the idea of us being made up of atoms, because if we human beings are made up of the same thing as the rest of the universe, that sort of makes us not special. Okay? So anyway, the idea of atoms, atomism, was elevated into a scientific thing. It became the basic assumption, or postulate assumption of a scientific theory around 1805, and this was done by an English school teacher named John Dalton. Okay, so he proposed what's known as Dalton's atomic theory, and this theory was able to explain a wide range of experimental facts. Okay, so the idea of atomism wasn't really used in science until around the 1800s. Alright, so exactly how small is an atom? Imagine atoms as spheres, okay? When you have those two atoms, when you have two atoms that are as close to each other as possible, as in a solid, okay? So in a solid, the atoms are as close to each other as possible. Then, typically, the size of the atoms are such that the distance between the centers would be around 1 to 2 angstroms. If I have a sphere here, and the closest atom nearby is right next to it, the distance from center to center is about 1 to 2 angstroms. And what's an angstrom? By the way, the symbol for angstrom is a little a, is capital A with a little circle on top of it. 1 angstrom is 10 to the negative 10 meters. So that is what? 0.00000000001. Right? There's 9 zeros behind the 1. That's how small it is, 10 to the negative 10. Okay. So imagine you have a row of atoms that stretches 1 meter long. Okay, how many atoms would there be in that stretch of, in that row of atoms? Okay, I'm gonna pause and give you a little time to figure it out. Alright, so what you do is you imagine, okay, you have one atom here, another atom here, another atom here, another atom there, and you have the length of this entire row of atoms is 1 meter, right? So the total length is 1 meter. So, do you know the distance between each atom? So let's just assume it's 1 angstrom. Okay, so that means this is 1 angstrom, right? And that's 1 angstrom. So let's call L1 the length of one atom. The diameter of one atom is 1 angstrom, which is 10 to the negative 10 meters. Okay, what are we looking for? Number of atoms, right? Number of atoms. What happens if you multiply number of atoms times the length of one atom? You get the total length, L, right? The value of 1 multiplied by how many gives you the total value. So now you can say, since we know the length is 1 meter, the length of 1 is 10 to the negative 10 meters. So the number of atoms is L over L1. It's 1 meter over 10 to the negative 10 meters. Meters cancel out. What's 1 divided by 10 to the negative 10? 10 to the positive 10, right? 1 over 10 to the negative x is 10 to the x. Okay? 1 over 10 to the x is 10 to the negative x. So you can say that that's 10 to the negative negative 10 or 10 to the positive 10. So what is 10 to the 10? That is 1 followed by 10 zeros. Right? 1, 2, okay. 3, 4, 5, 6, 7, 8, 9, 10. That's 10. So that's a billion. That's a million. That's 10,000 million. Or 10 to the 9th is a billion. So 10 billion atoms.